Hello students, welcome to Eshwari Thaniksha channel. Students, in this video we are going to study about p-pi bond and p-pi d-pi bond. So how the question will appear in NEET examination is a molecule will be given to you. For example, SO2 molecule will be given to you. In this it will be asked, find how many p-pi bond is present or p-pi d-pi bond is present. Like this example, one more molecule will be given, SO3. So in this also it will be asked, find how many p-pi bond is present and p-pi d-pi bond is present. So in this video we are going to learn about this, how to find. So first students, let us see what is this bond. So we know there are two types of bonds. So one is called as sigma bond and second type is called as pi bond. So here, and also we know that there are three types of orbitals present. So one is called as s orbital, second is called as p orbital and third is called as d orbital. So always remember that s orbital is not involved in the formation of a pi bond, whereas p orbital and d orbital is involved in the formation of a pi bond. So sigma bond is nothing but overlapping of the orbitals along the axis. So s orbital and s orbital will overlap along the axis. So this will result in the formation of a sigma bond, or s orbital and p orbital will overlap along the axis like this. So now this will result in the formation of a sigma bond. So coming to pi bond, how the pi bond will be formed is, so take one p orbital. So this is one p orbital. Take second p orbital. So overlapping sideways like this. So for this overlapping, two lobes are required. So here you can see this is one lobe and this is second lobe. This is one lobe and this is second lobe. So here these two lobes will overlap and here these two lobes will overlap. So two lobes are required for the formation of pi bond. So this results in the formation of pi bond. So now this is called as p-pi bond. So why it is called as p-pi bond? Because one p orbital is involved in the formation of a pi bond. So it becomes p-pi. And here one more p is there. So this also is involved in formation of a pi bond. Therefore it is called as p-pi bond. So coming to second type, take one p orbital. This is one p orbital and then take d orbital. So this is d orbital. So now overlapping of these lobes will take place. So this will result in the formation of a pi bond. So now this is called as p-pi d-pi bond. So can you see here, p orbital and d orbital is involved. Therefore it is called as p-pi d-pi bond. So students, always remember that whenever a single bond is present, so we will take A and B. So between A and B, single bond is present. In another case, between A and B, double bond is present. In another case, between A and B, triple bond is present. So always, if single bond is present, it will be a sigma bond. If double bond is present, one will be sigma bond and second one will be pi bond. If triple bond is present, one will be sigma, second one will be pi bond and third one will be pi bond. So this is an idea how you can know that how many sigma and pi bond is present. So now specifically we will take an example and find out how many p-pi and p-pi d-pi bond is present. So first example, let us take sulfur dioxide, SO2. So students, here what is the hybridization of SO2? For that, first write the structure of SO2. So the structure of SO2 we can write like this: S, double bond O, and here one lone pair of electron will be present. So how to find their hybridization? So I have already taught you a trick how to find the hybridization. So here we will be using steric number. So steric number is equal to the number of bonded atoms plus the lone pair of electron. So what is Ba? Ba is called as bonded atom. Bonded atoms. And what is Lp? Lp is called as lone pair of electrons. Lone pair of electrons. So now let us calculate the steric number. So let us calculate the steric number. So this is equal to number of bonded atoms. How many are there? 1 and 2. There are 2 bonded atoms. So you will write 2 plus how many lone pair of electrons are present? So you can see here 1 lone pair is present. 2 plus 1 is equal to 3. So if you get steric number as 3, then the hybridization will be sp2. So totally 3 orbitals are present. So the hybridization is sp2. So now let us write the electronic configuration for sulfur. So sulfur, it has atomic number 16. So electronic configuration, you can write it as 1s2, 2s2, 2p6, 3s2, 3p4. So now let me write the ground state electronic configuration. That is, this is 3s orbital and this is 3p orbital. So how many electrons are present here? So here you can see 1, 2, 3, 4, 5 and 6. So students, sulfur will have empty d orbital as well. So it is having 3d orbital which is empty. So 1, 2, 3, 4, 5 orbitals will be present. So now what we are going to do is we are going to shift one electron. So from here to here in the excited state. So excited state. In the excited state you can see so in the excited state here 2 electrons will be present, here 1, 1, 1 and 1 electron. So this is 3s orbital and here this is 3p orbital. This is 3p orbital and this is 3d orbital. So I'll indicate this as p orbitals. These are the p orbital and these are the d orbitals which are present. So students, now what is the type of hybridization? It is sp2 hybridization. So this s and 2p orbitals will be involved in hybridization. So this results in hybridization like this. So students, always remember that hybrid orbitals always form sigma bond. So sigma bond will be formed. So can you see here electron pair? This electron pair is nothing but this electron pair. So now these 2 electrons are present here. So these 2 electrons in the hybrid orbital forms sigma bond. So here can you see here sigma bond. So now, so out of this double bond, one will be sigma bond and another will be pi bond. One will be sigma bond and another will be pi bond. So one is involved in the formation of one sigma bond and another electron is involved in the formation of this sigma bond. So now here this pi bond is present. How many pi bonds are present? 2 pi bonds are present. So now we have to check whether it is p pi bond or p pi d pi bond. So now we will take oxygen atom. So how many oxygen atoms are present? There are 2 oxygen atoms. So I'll write here. So I'll write 1 oxygen atom here and then I'll write 1 oxygen atom here. So electronic configuration for the oxygen atom, if you see, it has totally 8 electrons. So electronic configuration you can write it as 1s2, 2s2 and then 2p4. So here I can write for oxygen. So this is 2s orbital and this is 2p orbital. And for another oxygen, same way I can write 2s orbital and then 2p orbitals like this. So in 2s orbital 2 electrons are present. In 2p orbital 4 electron, 1, 2, 3, 4. Same way for this oxygen 2 electron, 1, 2, 3 and 4. So now what will happen is this electron is involved in the formation of sigma bond. And this electron in this oxygen is involved in the formation of sigma bond. So now So this electron is going to combine with this electron. So can you see here, this and this. So this electron is present in, can you see here, it is present in p orbital, and here it is present in p orbital. So this will result in the formation of p pi bond. So second is, so there is one electron in this oxygen atom. Can you see this? This electron is going to combine with this electron which is present in the d orbital, and it results in the formation of d pi p pi bond. So now totally you can see that one p pi bond and one d pi p pi bond is formed in sulfur dioxide. So this is how we find. We will go for the second example. So second example is SO3 molecule. So students, write the structure of SO3. So SO3 you can write like this: S double bond O double bond O double bond O. So this is SO3. So find their hybridization. Use steric number. Steric number is equal to the number of bonded atom plus lone pair of electron. So the number of bonded atoms are 3 plus lone pair of electron is 0. So this will be equal to 3. So the hybridization is found to be sp2 hybridization. So now again we will write for sulfur electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p4. So now ground state electronic configuration, if you write, so this is 3s orbital, so this is 3p orbital, and this is 3d orbital. So this is 3d orbital. So here you can see in the 3s orbital 2 electrons are present, and in 3p orbital 4, 1, 2, 3 and 4 electrons are present. So if you go for the excited state, so in the excited state, if you see, so one electron will shift from here to here, second electron from here will shift into this orbital. So as a result, what you will get, so this is 3s orbital, this is 3p orbital, and this is 3d orbital. So one electron here, one electron here, one electron here. So I'll write this as d and d orbital. So all these are d orbitals. So this I'll write it as p orbitals. So 3p orbitals are there. So now we will write for what is the type of hybridization we have seen. So it is sp2 hybridization. So S and p2. So this is involved in hybridization. So this will result in the formation of a sigma bond. So can you see in the structure, one sigma bond, one pi bond, one sigma, one pi, one sigma and one pi bond is present. So now we are worried only about the pi bond. What is the type of pi bond is present? So this 1, 2, 3. So totally we have 3 pi bonds. So what is the type of pi bond we have to find? So let us write 3 oxygen atoms now. So one oxygen, second oxygen, third oxygen. So write its electronic configuration. So it has 2s and 2p orbital. So this is 2s and then this is 2p orbital. So let me write it as p. So 2 electrons here and then 4 electrons here. Same way for second oxygen. So this is 2s, 2 electron and 2p. So totally 4 electrons, 1, 2, 3 and 4. Same way for third oxygen. So this is 2s electron and this is 2p electron. So 1, 2, 3. So now 4. So now what happens is this electron is involved in the formation of sigma bond. So this electron is involved in the formation of sigma bond. So this electron in the oxygen is involved in the formation of sigma bond. So now see here the second electron. So first oxygen will combine with this p orbital. So you can see here P and P results in the formation of P pi bond. So here I can write this as P pi bond. So next we will see in the second oxygen. So second oxygen, the electron from here will combine with this. Can you see here? P orbital and then D orbital is involved in formation of pi bond. So now you can write this as D pi P pi bond. So now third one we will see. So third is here. So third oxygen. So one electron from here will combine with this D orbital. So can you see here? This is the P orbital and this is the D orbital. So this is involved in the formation of a bond. So this is called as P pi. So this is called as D pi P pi bond. D pi P pi bond. So students, totally 3 pi bonds are present, right? 1, 2 and then 3 are present. Can you see one P pi bond? Can you see second one D pi P pi bond? Can you see third one D pi bond? So totally 2 D pi P pi bond and 1 P pi bond is present in sulfur trioxide. So this is how we find the kind of bond in the given molecule. So students, I hope it is useful to you. So if you find it useful, subscribe the channel and also share this video with your friends. I'll meet you in the next video, students. All the very best.